In this video, I'll be explaining how to do the problem character recognition. So here we're given basically a dictionary or a font, and every 20 lines will contain one letter, and we have to see what letters are there inside this other file. But then some of the words might be changed, or some of the letters might be changed a bit. So you can have either one extra line or one less line, and also some of the zeros in the this input file will be changed to ones, and some of the ones will be changed to zeros. So first, here we can take a look at what we will do if no lines are changed. So if only some of the zeros and ones are changed, we can loop through each of the 20 lines in the input file and check the difference between that and every one of the letters inside our font file. Because this isn't that big, the input has at most 1,200 lines, and the font has always has 540 lines. So you can use two nested loops to find the difference. And also you can basically convert this whole zeros and ones into an integer, and then use XOR to get the difference in the bits. So here, this is what we will do first. We will first reading the input, and here I will read this in as a bit set, which has 20 bits, basically meaning that it has 20 digits, and then we'll convert that into an integer and store it inside this font array. Then we're reading the character recognition file. This is also the same. We read this as a bit set and then convert that bit set into a string, onto an integer, and then we can compare that with each of the lines inside our font file. So we'll get the difference between this current line and this other line inside the font file. And to do that, we will use XOR. So using exclusive OR, you will the ones that have the bits that are the same will be set to 0, and the bits that are different will be set to 1. So then we can use this built-in pop count to count how many set bits there are, and the amount of set bits will be the difference between these two lines. So here I will use this loop to check for each of these possible cases. This first case is when we have one less line. This is when we have no change in the line, and this is when we have one extra line. So first, let's take a look at the most basic part. So this will be if we have no extra lines or no less lines. So if we have no less lines or extra lines, we will just check this current line. So we will start at this current line inside our input file, and we will loop through 20 lines starting at this current line and check if it is equal to any of that inside the font file. So here this loop containing J will loop through each of the fonts, so each of the letters inside the font, and each of them will have 20 lines as stated in the problem. Here we will go through all of the lines inside this 20 line. So the 20 lines of this current letter that we're looking at from the font file, and we add the difference of this current line in our input file, and the difference, and also the line from the font file. So we're both starting at I, and we're starting at I and J, and they're both increasing by 1 every time. So we can use this K to both denote how many lines are already scanned. So we add this total difference into the C, and then here we will use a bit of dynamic programming. We will consider this current minimum amount of differences starting for this current line, and so we will check what happens if we add our current this current difference count. So this is difference. The C will represent the amount of different values inside this current 20 by 20 letter compared with the font file. So we can see if this is smaller than 20 lines, if this is smaller than the minimum amount of changes after 20 lines. So this is for the next, this when we're considering the next letter basically. So if it's less than that, then we should use this amount of moves. So for this next letter, I plus 20, we will assign it this minimum move value, because here this is the smallest move that we can do to get to all of the letters starting at 0 all the way to I plus 20. And then we will also keep track of how many lines we should skip. So basically this represents how many lines are used inside this current letter. So since we're looking at the if this letter has no less line or more line, it's just 20 lines, so we'll set this to 20. And then this this PC will keep track of what is the character at this position. So the character at that position will be set to this j divided by 20. And remember, j is the lines that you're currently looking at in the dictionary. And since there are 20 lines for every letter inside the font file, we just have to divide j by 20 and we will get which letter we're at. And I just copy pasted the whole thing, or you can type it out. Just all the alphabets in the sorted order with a space in the beginning. So we'll get whatever that is. And so this is basically the same for when we have one less line and when we have one extra line. But when we have one less line, we will see what happens if we skip one of the lines. So basically we're skipping one of the lines in the dictionaries and checking it with the current letter. And for one extra line, we're basically skipping one line inside our current word, inside our current character recognition file and not the font file. So one is skipping the font file, one line in the font file. The other one is skipping one line in the character files. So this is the first case when we're skipping one line from the font file because we have one less line than what it's supposed to be inside our character file. So here it is still the same. For the first loop, we are going to look at each of the letters inside the font file. And then using this second loop, we'll determine which line we should skip. So we can try all the possible 20 positions in this line. So because every letter has 20 lines in the font file, we can choose which line we want to skip and test what happens if we skip that line. So this is basically the same thing, still getting the difference. But here we should skip the line when it's when we are looking at is equal to this k. So k is the line we want to skip. And so here we should use another x to keep track of the position for our current line in the letter file. So here, although we're skipping, so when we skip this, we'll continue. This means that the lines that we're looking at in the font file will increase by 1. But we should still be looking at the same line for the character file. So we should use another position to keep track of which line we're at in the letters file. And when it's a different line than what we want to skip, then we will increase this x by 1. So here we're looking at the next line inside the character file as well. And then we also do the same thing, compare this with the next letter. But here, since we're considering if this letter only takes up 19 lines, we should look at I plus 19 instead of I plus 20. So this is basically the same as well, but here we're skipping 19 lines instead of 20. And then also set the character to j divided by 20, because here the j will represent the font file, the lines in the font file, and that never changes, so it's still dividing by 20. Then the same for the one extra line, but here instead of skipping, so basically instead of not increasing the position for our current character file, we'll increase one extra line for our character file. So then we won't have to look at one of the lines inside our character file, because this means that we've basically skipped that line and we're looking at the next line. So here still the same thing. also increasing this position by 1 every time. So finally here, we're also going to count the total difference that we have for this current line. If it's less than the total difference that we previously got for this for the line 21 lines after this current line, then that means this is the optimal answer for this I plus 21. And this is 21 because we are considering if this current character starting at line I has 21 lines. So we will assign this also value also 21, and then still assign the character at I plus 21 to the character for j divided by 20. And then here, this way we're using all of the lines inside the file, because that's what's required in the problem. We have to use all of the lines, and so finally here we should start at our n, and n is the total number of lines there are for our character file. So this will represent it all the way at the end, and while our current position is still not at 0 yet, this means that we still have more characters to add. So we should keep on subtracting this by the amount that we are assigned to skip. So this will keep on skipping until we skip to the 0. And here, since we're going to reverse direction, we should append our current answer to the character at our position or our line I. So this way we will be able to print this out in the correct order, since this is going backwards in reverse.